Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Thank you very much. Op amps. They are one of the most useful building blocks of electronics, and you can get them in various different packages like through-hole as well as SMD. But today's topic of this video is controlling an inherent problem with a lot of op amps, especially the NE5532, which is of DC offset. Now, these little ICs here, the NE5532, a P in this case, or is it a P? No, just a P, do have the inherent problem of there's a finite amount of DC offset on each of the input pins of, this is a dual op amp, so either channel. It's not that great, but I have seen these go up to nearly 30 millivolts DC offset on their output. Now, they have no DC offset null pins like the NE5534 does, as well as the TL071. But you can actually control the DC offset of just a dual op amp or even a quad op amp fairly easily. So we'll turn to the whiteboard and I'll show you what I'm talking about. Okay, here's a standard looking drawing of a dual channel op amp 8-pin package, using pins 3, 2 and 1 as the inputs and output respectively. We've got our input signal coming in here through a blocking capacitor with a 22K ground reference resistor to pin 3, the non-inverting input, so this is a non-inverting amplifier. For simplicity, this is just represented as a voltage follower, so this has a gain of 1 or unity, because pins 2 and 1 are connected together. You've got your supply pins 8 and 4, which is standard. But we'll notice over here, we've got a 1 mega ohm resistor connected to pin 3 to the center of a 100K variable resistor. Each side of that variable resistor goes to each polarity or each voltage rail respectively. So one side goes to positive, one side goes to negative. And what we're doing is assuming that this pot would spend most of its time in the middle to give 0 DC offset, varying it back and forth between positive and negative is applying a small voltage at the input here to null the offset voltage, which would actually be here. So say there was like 3 millivolts of DC offset on pin 3, applying minus 3 millivolts of DC to pin 3 would cancel that 3 millivolts out, giving you 0 volts DC. Now, the question is, does this actually work? Well, it should do, and I don't see any reason why not. Because we're now applying DC here to pin 3, does that mean we're actually going to have DC here on the output? Well, no, because we're not biasing pin 3 to the halfway supply voltage point or anything, so we wouldn't have half the supply voltage here at the output, mainly because of this high resistance here. Because what we're actually doing is just nulling whatever DC or offsets here on the input. So effectively the output should be 0 volt. So let's breadboard this up, and it should work as a standard non-inverting amplifier as well with feedback components. But for simplicity, we're just going to do it this way because it's less components to put on the breadboard. And also this should work for both types of op amp configurations, that is inverting and non-inverting. You just swap the position of which pin it's connected to. That's something I might also explore is change the configuration over to inverting and see if it still works the same way. So I'm going to breadboard this up. I'm going to not install these two components first because I want to get a baseline control. I want to see what the DC offset is currently in the configuration on the output, so we know how much there is, and also to see if this passes a signal. Because I bought some new op amps, I don't know if they work, so I wanted to see if they work. But yeah, so let me get to breadboarding this up and we'll do some tests. Okay, and a short time later, about probably 10 minutes later, I've got the circuit fleshed out here on the breadboard. I've forgotten a pin for our output point, which is here, so I'll just plug one in. But that's perfectly fine if I can get it into the board. I do not like this breadboard because it's very tight to get the components in sometimes. Right, so there's our output point. Now, this capacitor is a 1 microfarad 450 volt. It's overkill, but it was the closest one to hand that I had at the time, so we'll just go with it. So I've got the supply set to roughly plus minus 15 volts. Have to adjust one because it's too high. Close enough. And so I'm going to turn the supply on, and we're going to measure the DC on the output here, what its offset is. So I'll turn it on. Right, I've got no unusual current draw, which is good. Okay, so I'm going to use this multimeter for the job because it's just handy to do it on camera. And I don't know how well you can see that. Hopefully you can see it. Over there maybe? Yeah, it's good enough. Alright, so between ground and output, we have about 3 millivolts. Okay, now 4 millivolts. That's fine. I don't know if I can do this, but yeah, it is moving around, so it should be working as an amplifier. So what I need to do is connect up a oscilloscope to it first and just verify that it is passing a signal. So let me get my portable oscilloscope for this. Okay, so we've got the oscilloscope now connected to the circuit. I'm using the portable one, as I said. We've got 1 kilohertz going in and roughly 10 volt peak to peak coming out if we're in times 1, which we are not. So I have to change that to times 1, which is an awfully long way around of doing it. There we go, that's better. 1 volt peak to peak out. Much better. So that would mean that we've got 1 volt peak to peak going in as well because it's a voltage follower, which is fine. So now that we know that the circuit is working as an amplifier, well, at least a voltage follower, now let's insert the potentiometer and the 1 mega ohm resistor to see if we can actually tune that DC offset. So to do this, we want no input signal, so I'll kill that for that purpose. And let me add some extra components to our breadboard experiment here and do some further testing. Okay, a short time later, I've got the circuit now configured with the pot, and I've set it roughly to the middle. Power supply is still off. I've got the 1 mega ohm resistor going to pin 3 from the center of the pot. Each end of this pot is going to either supply rail. So I've got the multimeter measuring in millivolts the output voltage. So I'll turn the supply on. No unusual current draw, but immediately we've got 12 point, well, we did have, and it's now dropped. It could be a connection issue too. So let me just bury this pot. And as we can see, we can actually control the DC offset. And if I do this and hold my tongue right, ooh, very close, we can see that we can get almost 0 DC offset, which is excellent. It's just very touchy because it's a single turn pot. If there was a multi-turn pot there, it would be a lot more precise. But as we can see, we've got exactly 0 volts. So if I now touch the input, which is not going to do anything because it's grounded, run the oscillator, well, the DC component's not changing. However, is this still outputting an audio signal? Let's find out. Bring the oscilloscope back in, and I will connect to the output and ground. Yep, we've still got an output signal. We're still at 0 volt DC, and we're still pushing out 1 volt peak to peak roughly, which is about, I think it's 400 and something RMS. Where's the RMS value? 380 millivolts RMS. So yeah, that does work for the non-inverting amplifier. The offset has moved a little and it's shot back up and is moving back down again. But it could be this pot too. Close enough. for what I'm dealing with here. Now this could be useful also not just for nulling DC offset, but for introducing DC offset into an amplifier stage for whatever reason you want to do it. So if I give it like a lot of DC offset, we're up to, well, it's trying to correct it, but 326 millivolts DC offset. As we see, this, it doesn't really degrade the output signal, but if I move the pot back and forth, we can see the signal jumping up and down. But now, for some reason, it's because it's come unplugged. Plug that back in. I was about to say I couldn't get a 0. Now I can. Okay, so let's turn our attention now to an inverting amplifier. It's essentially the same thing and theory as the non-inverting amplifier, except we're now got an input resistor and a feedback resistor, both the same value here. So this is a voltage follower, so a gain of -1, or it's still unity gain. The values of these resistors aren't important. It could also be a gain stage as well, and the theory will still work. But just for simplicity, I've chosen two 100Ks because there just happens to be two sitting on my desk. But we now connect a variable potentiometer and the 1 megaohm resistor to pin 2, which is the input we want to control. Pin 3 just goes to ground, as it does in a normal standard inverting amplifier configuration. So what I'm going to do is I'm going to build this up on breadboard, just make the modifications, and then we'll test to see if we can still vary the DC offset the same way we did with the non-inverting amplifier. Let's go. Circuit's reconfigured and the multimeter is measuring the output. Power supply is off, so I'll turn it on. And 9 usual current draw, about 4 millivolts of DC offset. Let's vary the pot, which is not doing anything at all. But that could be where I've placed the pot. Okay, so maybe that needs to be on the input side of the resistor, not where I've got it. So I'm going to have to reconfigure it again and have a play with it and see what's going on here. Just give me a minute. Okay, never mind. The output pin was shorting back to the input, so that's why it wasn't adjustable. So I've got a pair of pliers holding the lead away from it. And if I do adjust the pot, it is varying, but it's very finicky. And it's very hard. Well, I have sort of got it down, but it is very hard to adjust. Okay, we'll go with that, although it's creeping back up. I did try it on the other side of that input resistor, and it does still vary, so I don't think it matters where it goes, to be honest. Just to prove that fact, I'll disconnect it from where it is, and I'll put it over to where I connected it, which was at the input, before the capacitor, etc. And actually, to be honest, that's much more easier to adjust. Yeah. So I'm going to say that putting it before input resistor before pin 2 is where it should be going, not where I drew it on the diagram. Okay, so we've just proven that fact there that I'm wrong, which is not a uncommon thing here. But yeah, it is adjustable, and that's a much more satisfactory way of adjusting it. Now we're down to 0, as we can see right there. However, is it still working as an amplifier and passing a signal? Well, let's find out. So if I move the multimeter out of the way and I bring the oscilloscope back in to play here, and I'll just leave the multimeter connected because the pliers are helping hold that pin away from pin 2 and shorting it out. Find a suitable place to ground, which is there. And then I connect my input signal without shorting stuff out to the input and ground. and run the oscillator, there we go. We have a output signal, and pretty much the same signal output voltage as the non-inverting amplifier, 1.02 volt peak to peak, or 380 millivolt roughly RMS. Wonderful. So there you go. There's a practical demonstration of how we can adjust the DC offset of a op amp that doesn't actually have DC offset nulling capability. So here we are. It's the same as it was before, but this is where that adjustment pot should be. And I've put 4 meg 7 here because it probably yield a much easier adjustment, less touchy. You could probably increase the value of the pot to say 500k to get an even more smoother adjustment there. But yeah, that's basically how we get rid of DC offset on a op amp IC that has no offset null capabilities built in. Unlike the NE5534, TLO71, etc. They have offset null capabilities. In the case of the TLO71, they call it balancing. So anyway, I hope someone found this video helpful.
I'm the Astro 30, and if you enjoyed this video, please remember to go down below, like, comment and subscribe if you haven't done so already. And as always, this is the Astro 30 saying see ya, thanks for watching, have a great day.